Alright, so in this section what we'll do is, or in this part of the practice test, what we'll do is start looking at problems involving the law of cosines. And well, one of the ways that you can tell that you would need to actually use the law of cosines, if you try to use the law of sines, you'll see in just a sec what happens. So let's suppose we try to use the law of sines on number 26. So we would say the sine of 52 over its opposite side, which we don't know, we'll call that x, equals the sine, and then notice there's no other angle here. So let's say we call this angle, we'll call it angle B, the sine of angle B over its side, which is 29. Problem with trying to use the law of sines here is you can't. If you cross multiply this, you're going to have x times, that's a variable, times sine B, that's another variable, and you can't solve it when there's two variables. So when you can't use the law of sines, what you should use is the law of cosines. And this is the law of cosines right here. It's kind of like the Pythagorean theorem, a squared plus b squared equals c squared. But then this other part to it is the correction factor. And this is basically the Pythagorean theorem for triangles that are not right triangles. The other reason that we don't have to use the law of sines, and we know that there's no ambiguous cases, is because they actually drew the picture for us. So we don't need to guess here. There's no other triangle we could have if they drew that picture for us. Alright, so in this case, and by the way, the other thing is the angle that they're giving to you is always opposite to that side. So even though I used C here, the angle they actually give us was 52. So don't be confused by that, those letters here. I mean, I won't cross them out just because our answers have to have them, but don't think that the C in this equation right here is going to be the same as this angle C. That's just how we normally set it up. Alright, so the angle they're giving us is 52, so that means I'm going to take the cosine of 52, and the side that's opposite to it is this one, okay, which we'll call x. I don't know x. And then I just need to take the other two sides. So the two sides they give us are 28, so we're going to square that, and then 29, we'll square that. And then notice that a are the same here, b is the same here, so we're going to do 2 times those two numbers, 2 times 28 times 29. And now all we need to do is just plug that into our calculator, basically. One thing I want to show you, though, just to avoid a common mistake here. 28 squared is 784. 29 squared, I think, is 841. So when you add those together, you get 1625. And then this stuff here, 28 times 29 is 800 and, what is that? 812, I believe. That seems right. 812, and then minus the 2 would be 1624. Now here's a mistake that some people make. Some people say, well, 1625 minus 1624, that's 1, and then I still have that cosine 52. This is wrong because that's an order of operations mistake. These are being multiplied, and those are being subtracted, and you have to multiply before you can subtract. That's what PEMDAS says. So let's put this in a calculator. Let's put 1625 minus 1624 cosine. And you didn't actually have to multiply those out. I just did it to be sure that we got it. And we're going to get 625, and that's equal to this number squared. So we want to square root that. So we will do second square root of the answer. See what we come up with. We wind up with 25. And, well, that's a problem because all three of these sides are 25. So at least we know that's 25. But now we need to do some other stuff. Now here's the nice thing. Once we have that third side, now we don't have to use the law of cosines anymore. Now we can use the law of sines. So at the very least, this helps us to narrow these things down. So that's 25. Now we can use the law of sines. So we'll say the sine of this angle over its side, sine of 52 over 25. And that's going to be equal to the sine of any other angle. So let's just take this one, the sine of b over its side, which is 29. Okay, now we can cross multiply like we've been doing before. So let's do that. And we're going to end up with 29 times the sine of 52 degrees is equal to 25 times the sine of b. We'll divide both sides by 25. And then to find what angle b is, we need to cancel out the sine. And we do that by taking the inverse sine. So those will cancel. And then obviously whatever we do to one side needs to be done to the other. So the inverse sine of that number should be whatever angle b is. And if you look up there, angle b has 4 different values, 68, 65, 69 degrees, and 66 degrees. So obviously one of these is going to be correct. So let's do inverse sine of 29 times the sine of 52 degrees. And actually, instead of using that rounded answer just to make it a little bit more accurate, this 25.000 part, I'm going to do divide by second answer, because that means dividing by that exact number rather than some rounded answer. If we do that, we get 66 degrees, and that means it has to be option D. And we could also find the missing angle. 66 plus the 52 would be 118. That leaves 62 degrees left over, so it has to be option D. Number 27 is another law of sines problem with one difference. This time, okay, you notice on the other problem they gave us two sides and they gave us an angle. Here they're giving us three sides but no angles. And again, you could try to use the law of sines, but what you'll find is you'll have multiple variables. It won't work. So let's simply use the law of cosines again. That's the only one that's going to get us something that works. It doesn't matter what angle we find, but because this version of the formula has C in it, let's just start by finding angle C right there. So all we need to do is match up. So C corresponds with the 10 side. So I'm going to do 10 squared is equal to, actually, sorry, let me correct something for a sec. When you're doing the law of cosines, in order to avoid problems or mistakes, it's actually better to use, and I think we explained this in the other video, it's better to use the biggest side as your C. Okay, because you might wind up, at least if I remember correctly, there are some cases where you might wind up with one of these ambiguous cases, which is not supposed to happen. But because we're over here, we end up taking the inverse sign. Okay, that's going to cause a problem if we don't use the biggest side. So let's start by using the largest side as our value. So 17 squared, that means we're finding this angle. 17 squared equals the other two sides squared. So 11 squared plus 10 squared, which is the number 221, minus 2 times 10 times 11. 2 times 10 times 11 is 220. And then we have the cosine of, it's actually this angle, angle A, that we're finding, because that's opposite to the 17 side. 17 squared is 289. Okay, now how do we solve this? We want to isolate the cosine A. So let's subtract 221 from both sides. 289 minus 221 is going to be 68. And then we have negative 220 cosine of A. Let's divide both sides by negative 220. Those will cancel, and to cancel out the cosine, what we need to do again is now take the inverse cosine. So the inverse cosine of negative 68 over 220, we will see what that gives us, and hopefully it's going to give us angle A, because you can see there's 4 different values for angle A, so we can actually just stop right there. Okay, so let's see, inverse cosine of negative 68 over 120. Make sure to use the negative sign, not the subtraction sign. And let's see what we end up with. We end up with 108 degrees, so it must be this one. We could check using the law of sines for the other ones, but that's the only one that has 108, so we really don't need to go any further. Okay, for these, for 12.7 and 12.8, I think in another page you're going to talk about graphing this, so I'll show you how to do that. But first thing we have to know for graphs is we need to know what's called the amplitude and the period. Okay, the amplitude, here's a really simple sine graph. Okay, sine looks like this. The sine of 0 is 0. The sine of 90 degrees is 1. The sine of 180 degrees is 0. These are called periodic functions because they repeat. There's like a period to them. And in this case, and the sine of 270 is negative 1, and then the sine of 360 is back where you started at 0. So when you connect the dots, you get this kind of wave type function. Looks roughly like that. And the amplitude is the distance from the middle of the function, what's called the midline. Midline is this one right here. It's the line that literally goes through the middle. That's called the midline. Distance from the middle of this function up to the peak, or the middle of this function down to the bottom. And in both cases, this is 1, and the midline's at 0. So the amplitude is 1. Okay, if you start putting numbers in front of it, so this graph that I just did is y equals sine theta, or 1 sine theta. This is the amplitude. Whatever number's in front of it, it's going to stretch it. So this, or shrink it in this case. You take all of these 1s, and this would actually shrink it to 1/4. So the amplitude in this case is 1/4. Okay, the period of a regular function is how often it repeats. So you can see it starts here, goes to a peak, then it goes to a low, and then it's back at its starting point. This distance here, the time that it takes to go through one complete cycle, for the regular sine function, it's equal to 360 degrees. However, if you put a number right here, it takes 360 and it ends up dividing it by that number. So 360 divided by 3 is 120 degrees. that's the period. This basically means it's going to cycle through 3 times faster. So instead of taking 360 degrees to get there, it will take 120 degrees. So there's our two values. Okay, this one right here, the amplitude is right there. The period is going to be 360 divided by that number, and that turns out to be 72 degrees, which means it's going to go through 5 times as fast. It's going to go through 5 cycles in 360 instead of just 1. All right, knowing this, we can now graph these. So there's a little guide that I wrote up here, and it looks like this: how to graph trig function. And they just give you a couple steps. It says, first step, find the amplitude, the shift, which there isn't one on the one we're about to do, the period, and the translation up or down. Okay, so you can see these top of the page right there. Those are the basic functions, and they give you those values: a, b, theta, h, and k. A is the amplitude. 360 divided by that b number is the period. The h part is, you may remember from earlier chapter, add to x go left, subtract from x go right, so that tells you whether you're going right or left. And the k outside is the up and down translation. Okay, so that's our first step, is figure those things out. Then we'll make a table of values, and we always start the table of values whatever number makes the parentheses 0, and then we increase by the period divided by 4. And the reason you do that is on a circle or on a sine function, there are 4 significant places. There's 90, 180, 270, and then 0, 360. So important things happen at those 4 places. So we'll increase by 4 each time. Okay, so this right here, this is going to take the graph of sine. Let me move this over for a second. I know it's multiple choice. I just want to show you how to graph it if it were not multiple choice. This has an amplitude of 1/2, this number right here. It has a period of 360 divided by, and that's like 1/4 theta. So we're actually dividing by 1/4, not by 4. That's like 360 times the reciprocal of 1/4, and that's 1440. Okay, so let's start to set up our graph, and then we have the period. We don't have any shift right or left. There's nothing happening in the parentheses. So when we start our table of values, we're going to start at the value that makes the theta part of this equation 0. And the only way to make that 0 is with 0. Okay, then we need to divide the period into 4. The period we said was 1440. So 1440 divided by 4 is 360. So that means we're going to go up on this graph every time by 360 degrees. And we want 1440, the last number right here should be the amount of the period, which he says 1440. We want 5 things in that table because this is the starting point and the ending point is the same. And just to make sure that we have it, our ending point should be the same as the starting point. So now how do we get our graph? We just fill this stuff in. So this is going to be y equals 1/2 sine of 0 divided by 4 is 0. The sine of 0 is 0, and 0 times 1/2 is 0. So there's our first point right there. Okay, next point, y equals 1/2 times the sine of, now we're going to plug in 360. So 360 divided by 4 is 90, and the sine of 90 is 1, and 1 times 1/2 is 1/2. Okay, so let's kind of label this. This is 1, so at 90 degrees, sorry, at 360 degrees, we should have a point at 1/2. All I'm doing is labeling this. It doesn't really have to be drawn to scale. You just have to label it to show that you are kind of setting this up correctly. So there's our 5 points. That's all we need is 5 points. We'll plug in 720 right here. 720 divided by 4 is 180, and the sine of 180 is 0, and 0 times 1/2 is 0. So this is good because we're getting something that looks like a sine curve. It's been shrunk by 1/2, but that is what it's supposed to have done. Okay, now we'll plug in 1080 for this theta right here. These are different colors so you can see it again. How are we getting these values? I'm plugging in for theta. So 1080 divided by 4 is going to give us 270. And notice the values that are showing up: 90, 180, 270. Those are the things that we said before are important right here. Here's 90, here's 180, here's 270. This is how you know you're doing it correctly if those significant, what are called quadrant angles, are showing up, because they're angles that occur in the quadrant. Okay, this sine of 270 is -1 times 1/2 is -1/2. So let's say this is -1/2 right here, this is -1. So that occurred at 1080, so we'll put that right here. And then finally, this should actually be the same as the starting point. So if you plug in 1440, that's sine of 360, which is 0, times 1/2 is 0. And we are back where we started, and we get this picture right here. So let's figure out which one of these multiple choice ones are options. Well, this one has the wrong amplitude and period, so does that. These C and D both have the right ones, so let's see which one of these would be correct. Okay, so we should have points at 0 and 0. Okay, those match up so far. Then let's see the difference. Okay, you can see these are, it looks like we skipped one here, but that's 360 and that's 720. This is 362. So where are we supposed to be at 360 degrees? We're supposed to be right here at 1/2. So if you look at C and D, which one actually has 360 being at 1/2? It looks like this one. That's a half. This is a 360 at 0. So it looks like it's either another shifted sine curve or it might be a cosine curve. That has to be C. Alright, this one right here, let's see if we have, yeah, this is kind of the same thing, but these are the simpler versions. So amplitude here is 3, period is 360 divided by 3, which is 120. So let's just get rid of wrong options. These have the wrong numbers here, 3 and 120. Actually, this is the only one. It has to be that. So we'll save ourselves some time on that. The amplitude goes from 3 down to 0, and then down here to -3. The period should be 120. So you can see when you start to plug these things in, they give you several periods there, but a full period, a full cycle is 120, which would be, if you look at this picture here, that's going to be about right here. Okay, it starts at a complete cycle goes right there. So now I'll show you kind of one of the more complicated graphs. We'll do both of these. So this is number 32, and we'll use this setup that we just talked about right here. Okay, which is make a table of values. We'll go through this process just so you can see how it looks from start to finish. So let's start by finding the amplitude is right there, and the period is going to be 360. This is 1/4. So we did that before. 360 divided by 1/4 is like 360 times 4, and that's 1440. So let's get rid of the wrong ones right away. This one could be right, this one could be right, and so could this one. This one is definitely wrong. Okay. So now let's make our table of values. Okay, so here's our function, and I know this is multiple choice, but on some types of questions you do have to do these by hand, so it's better to kind of see how that looks, just so you can see how it's done. Okay, now the very first step is we want our first x value to be what makes this thing equal to 0. Okay, because if you look at this 45, add to x go left, that means we've shifted to the left 45 degrees, and this right here means go up 1. Okay, and then the 3 in front means vertically stretched. So we want to figure out what makes that equal to 0. How can we do that? We can set it equal to 0 and solve. So we'll subtract 45 from both sides, and we'll get theta over 4 equals -45. We'll multiply both sides by 4, and -45 times 4 is -180. So that's where we should start, because that is going to make 0 get plugged into this. Okay, so we already know this is 0 because we're plugging in -180 for theta, and that whole thing's going to be 0. 3 times the sine of 0 is 0, and 0 plus 1 should be 1. Okay, and that makes sense because we're taking the graph and we're shifting it up 1. Normally sine starts at 0, or the midline is 0, but in this case we've shifted it up 1, so it should be 1 this time. Okay, next question, how do we figure out what to increase by? And we said before that it involves taking the period and dividing that number by 4. And why 4? Because on the axis there's 1, 2, 3, 4 significant places. So that's why we're dividing it by 4. This turns out to be 360, so that means we're going to increase each of these table of values by 360. So -180 plus 360 is 180. 180 plus 360, that's 540. 540 plus 360 is 900. And then 900 plus 360 is 1260. And notice that we shifted at -180. If you add 180 to this last one, you do get 1440. Okay, you don't have to worry about that if that's confusing, but that's just another check. Alright, so remember, if we're doing this correctly, the numbers that should be getting plugged into this table of values are 0, 90, 180, 270, and 360. We did get 0. Okay, let's make sure we get 90 here. So we're going to take 180, we're plugging it in for theta, and then we're adding 1. Oops, let me move this over so we have more space there. Okay, so here's what it looks like. So we're going to get 3 times the sine of 180 divided by 4 is 45, and then 45 plus 45, that is 90. And that's a good sign because we wanted 0 and 90 next. Okay, and then we have the plus 1. The sine of 90 is 1, and 3 times 1 is 3, so 3 plus 1 equals 4. So these are the points on our graph. We're going to have a point at negative 181, at 184. Okay, let's fill in these other ones. So this is going to be y equals sine of, now we're doing 540 divided by 4 plus 45, and then plus 1 outside. Okay, sorry, that's supposed to be a 3 sine. 3 sine, 540 divided by 4 is 135, and 135 plus 45 is 180, and that's what we wanted. We wanted 0, 90, now 180. The sine of 180 is 0. 3 times 0 is 0, plus 1 is 1. Okay, and just to save a little bit of time, when you plug in 900 here, this turns out to be 900 divided by 4 is 225 plus 45. You're going to get 270 there. And when you simplify, sine of 270 is 1. Sorry, negative 1. 3 times negative 1 is negative 3 plus 1 gives you negative 2. And then when you plug in the last one, you wind up back where you started. So now all we need to do is find where those points are graphed. So we're down to, we had 3 choices. Let's look for negative 180 comma 1 as our first point. So negative 180 comma 1, actually we can't because they don't show you the negatives on here, so we need a positive number. So let's start with 180 comma 4. Let's see where that is, if anywhere on these graphs. So 180 comma 4, well, it looks like again we're going from 0 to 720 in 2 jumps, so this must be 360. Okay, this one also has to be 360, which means halfway would be 180. Well, this doesn't go to 4, so that's definitely wrong. They don't show you a peak of 4 right there. This one doesn't show you a peak of 4 either. This one does though. This is halfway between, that's 360. Halfway between 0 and 360 is 180, and we're supposed to have a point at 184. Okay, so that one works. And we should have a point at 541. So let's check 540 comma 1. 540 will be right here, and that does look like it's at 1. We should have a point at 900 negative 1. So 900 is going to be here, and there's, sorry, actually 900 is halfway between, and there's negative 1. And then finally 1260. 1260 is, each one of these little dashes is 360. That's 1.5 dashes after. That should be at 1, and there it is right there. So that does work out. It's a little bit hard to tell with those multiple choice ones, but if you graph it by hand, it would probably be easier. Okay, same problem here. The only difference is now we're in radians instead of degrees, so we can still deal with that. Let's just change pi over 4 into what it is in degrees, which is 45. It's a little bit more intuitive. Obviously on the graphs here you can see these are all in radians, but we can easily change them to degrees. Okay, so then we have an amplitude of 3. So this one is open, this one is open, this one's wrong, this one is possible. The period is 360 divided by that number. Okay, which is 90 degrees, and in radians 90 is pi over 2. So this one is still possible, this one is still possible, this one is still possible. We can actually get rid of the graphs though, because, not yet actually, I was going to say we can get rid of some of these graphs, but we don't want to do it by sight. So I'm going to graph this one by hand this time just so we can get a better picture. So here's our graph, and let's make a table of values below that. Okay, so table of values will go right here. And this is going to be y equals 3 cosine of 4 theta minus 45 degrees. That's that equation up there, minus 2. So the minus 2 means it's been shifted down 2. And here's the other thing we want to do, and this is a little bit confusing. We want to take this 4 and we want to factor it out. So in other words, we want to divide 45 by 4. And when you do that, you're going to get 11 point, let's see if this is right here. We're going to divide that by 4. Yeah, this is going to be 11.25 degrees, which seems kind of like a strange number. Let's just verify. Yes, if you were to distribute that 4 back, you would get 45 degrees. So looks like it's been shifted very, very slightly to the right, 11.25 degrees. Okay, so it's actually, sometimes it is easier to work in radians for problems like this, but we'll stick with degrees because that tends to be more intuitive. Alright, so then we have this table of values. So the first question is, where do we start this table? And the answer is we start it at the x value that will make this thing equal to 0. So let's set that equal to 0, and we will add 45 to both sides. And then when we divide by 4, we end up getting theta equals that number I just said, 11.25 degrees. So not the most convenient number because of the because of the decimals there, but it will work out when we plug it in. Okay, then the next question is how much do we go up each time? And by the way, we need 5 things in this table. How much do we go up each time? We go the period divided by 4, and the period is 90. So 90 divided by 4 is 22.5 degrees. So that's how much we're going to increase each time. So we'll go up by, whoops, didn't mean to move that. We'll go up by 22.5. So 11.25 plus 22.5 is this number. If you increase another 22.5, it's going to be 56.25. Next number will be 78.75, and the last one increased is going to be, what's that going to be, 101.25. And now how do we get these values? We plug them in like we've done before. So y equals 3 cosine. We know already when we plug this in here we were going to get 0 because we got that before. Cosine of 0 is 1, and 3 times 1, that's going to equal 3. 3 minus 2 is 1. So 11.25 degrees, comma 1. So let's plot that point right here. So here's 1, and I'm going to put that right there. 11.25 is not necessarily going to be drawn to scale, but there's 11.25 degrees. Okay. Next point, 33.75. Again, we want the numbers to go 0, 90, 180, and so on. So let's make sure we get that. When we plug in 4 times 33.75, that equals 135 degrees. And then when you subtract 45 from that, you get 90. So this turns out to be 3 cos 90 minus 2. Cosine of 90 is 0, so that whole thing is 0 minus 2, which is negative 2. So we have a point at 33.75 degrees, and then the low point is negative 2. So I'm sorry, this is getting messier than I intended to. So let me clear this off here, and here's negative 2. Alright, so at least we have something that's starting to look like a cosine curve. Let's see if we keep that momentum going. So when you plug in 56.25 here, 4 times that number is 225, and 225 minus 45 is 180, and that's what we want to show up. Cosine of 180 is going to be negative 1. 3 times negative 1 is negative 3 minus 2 gives us negative 5. Okay, so now, yeah, I definitely didn't leave enough room, so I have to clear all this stuff off here so you can fit this. Okay, so negative 5, here's negative 2, so we need negative 3, negative 4, negative 5, and there should be a point at 56.25, comma that number. This makes sense, by the way, because we're supposed to have the graph shifted down 2. That's what that minus 2 means. Okay, so, and that's kind of what cosine looks like. It starts at its peak and then it moves up. Okay, the next two should be 78.75 degrees, and finally 101.25 degrees, and let's just verify what happens. When we plug in 78.75 degrees, this parentheses does come out to be 270. You can verify that, but it definitely does work. It's 315 minus 45, which is 70. Cosine of 270 degrees is 0, and 0 minus 2 is negative 2. So you can see it's kind of going back up. This is exactly what cosine is supposed to look like. It's supposed to, these points right here are supposed to match, which they do. And then the last one should be the same as what we started with. I erased it, but we started up at a peak of 1. So this last one, when you plug it in, you get 3 cosine 360 minus 2. This whole thing is equal to 3, and 3 minus 2 does equal 1. So we're back up where we started. That is a complete period. Now here's the tricky part, is actually finding this graph over here, because our graph only goes through one period. They go through several. So let's see where it goes. So we should have a peak of 1 and a low point of negative 5. And this one might work. That one does have a peak of 1. This one doesn't work. Okay, does B have a peak of 1? No, it has a peak of 2, so that's wrong. So the only one that must work is A. Alright, very last problems on the practice test. These are actually a lot easier. The only thing we have to do here is solve each equation. To cancel out the sign, let me rewrite this here. To cancel out the sign, we need to take inverse sign. But there's only one thing to be aware of, and that is we need to solve it for everything from 0 to 360. So that means there's going to be 2 solutions. And I'll show you why. Okay, the inverse sign, that basically means what angle has a sine. That's what inverse sine means. What angle has a sine of negative 0.32? Let's draw the unit circle here. Sine is the y-coordinate. Sine is the y-coordinate on the unit circle. So if you look at the unit circle, let's just mark these points right here so we can see them. on the unit circle, the radius here is 1, so that point would be 0, 1. That means this point is 0, negative 1. This point is 0, that's 1, 0. And this one is negative 1, 0. So the question is, where is sine negative? Sine is negative in these two quadrants right here. Where is it negative 0.32? Well, here's negative 1. Negative 0.5 is maybe right here. So let's say negative 0.32 is roughly here and here. Those both have the same y value. So here's the angles we're looking for. We're looking for this angle right here. And then let me use a different color here. We're looking for this angle right here. Okay, so how do you find that? Well, let's put in inverse sine of negative 0.32, and what's probably going to end up happening is we will get, just recall what kind of number we're going to get. I think they might give us the reference angle off the top of my head, slipping my memory right now. But yes, we do get the reference angle, negative 18 degrees, or really 18 degrees, so 18.66 I think was what it was. So remember, negative angles, let's write that, negative angles mean go clockwise. So that, let's say this angle right here, that's negative 18.66. So how do we find the actual two angles? Well, the green angle is going to be all the way around except for that 18.66. So 360 minus that would be 341. Okay, and then how do we find this other one? Let me put it in yellow. This angle right here is also 18.66, but it's 180 plus that extra 18. So 180 plus that angle will be 198.66. Very easy to check if we did this correct, by the way. So let's just take the sine of that angle, and we should get this number right here. We should get negative 0.32. So let's take the sine of 198.66. It'll be slightly off because we rounded, but 198.66. I'll add a couple other of those decimals there. So I'm just copying those decimals that are right above what you see me typing. Negative 0.32, that's roughly correct. And then let's check the other one. But again, it's hard to get these wrong, because even if you do get it wrong, you can check them on a calculator. So what was the other one? 341.34, I believe. It's going to be slightly off because we rounded, but that's roughly negative 0.32. So there's our two solutions. Okay, let's see what happened here. We're asked to do it in radians or degrees. I'm going to see how they are getting it. That has to be a typo because 3.47 does not make sense. Okay, you know what this is? For some reason they put this in radians. So yes, that's those. We do have the right answers if they're in radians. So just to verify how you would convert those, so I can prove to you that these are the same answers. So that's in degrees. If you want to convert something to radians, you do pi over 180. So let's plug this into a calculator, and it's going to turn out to be this number right here. I'm not sure why they said solve in degrees but gave us an answer in radians, but they did, so let's verify. So 341.34 times pi. So times, let's see, where's the pi key? Times pi, and then we're going to divide that by 180. We should get 5.96, and we do. So yes, these are the answers that we had, except they just put them in radians instead of degrees. All right, last one right here. We'll take the inverse cosine of negative 0.54, because that's how we're going to cancel out the cosine. And again, they will give us the reference angle. Or sorry, they won't give us the reference angle. The way that inverse cosine works is it gives you any angle from the first to the second quadrant. So 122 degrees is in the second quadrant. Sine gives you angles in the first and the fourth quadrant. So here's our unit circle. Cosine is the x-coordinate. And remember, x goes from negative 1 right here over to positive 1 right here. So if we're asking where is x equal to negative 0.54, well, it's going to be roughly halfway between. So maybe right here and right here, roughly. Let's say that's an x of negative 0.54. Okay, and then actually, sorry, this one is not a negative x. The other negative x would be down here at negative 0.54. So we're looking for these two angles. We're looking for this angle right here, which we just found on the calculator. They told us it was 122. Okay, so that's this angle right here. And then how do you find this angle? Because this is the other one we want. We want this orange one right here. And the answer is that the orange one is going to have the same reference angle as this one. And the reference angle here is going to be what takes you down to that 180, what takes you down to that x-axis. We could find that by subtracting. And this turns out to be 57.46. That means this angle right here is 57.46. what's the big orange angle? It's 180 plus that 57. And that turns out to be 237.46. If you plug the cosine of this in a calculator, or the cosine, not of that, but the cosine of this, you will get negative 0.54. Let's just check the 237 one, because that's really the only one we haven't checked. So cosine of 237.46 should be negative 0.54, or very close to it, and it is negative 0.537, rounds to negative 0.54. So that is the Chapter 12 practice test. Hopefully clarify some confusions you might have had on trig.